Today we're going to look at the other portion of the non-parallelograms. So remember, these are quadrilaterals, so they're four-sided polygons, but we're looking at non-parallelograms. We've already looked at the trapezoid and the isosceles trapezoid. Now, unrelated to that, because it's its own offshoot down our hierarchy, is the kite. The kite might be a shape that growing up or when you were little you may have called a diamond. I know a lot of my kids' books and things call it that. There actually is no mathematical shape technically called a diamond. It would be called a kite or a rhombus depending on what its properties were. So kites have two pairs of consecutive congruent sides. Remember, a parallelogram had two pairs of opposite congruent sides, but these are consecutive congruent. So consecutive means in a row. Like if someone gets hits in consecutive at-bats, that means one at-bat and then the next one immediately following it. So when we're talking about consecutive angles or sides, we're talking about ones right next to each other. So these two sides right next to each other are congruent, and then these two right next to each other are congruent. And that's what gives us our kite. The kite actually has four properties that are true about it. One of them is that it has one pair of opposite angles that are congruent. It's not two pairs of opposite congruent angles, that's the parallelogram. Just one pair of opposite angles are congruent, and that pair is very specific. It will be the pair that connects the two different lengths together. So here we have one tick mark and two tick marks coming together to make this angle. And down here, one tick mark, two tick marks coming together to make this angle. These are the two angles that will be congruent. It's always the two where the different lengths come together. Another property is that the diagonals intersect at a 90-degree angle, or the diagonals are perpendicular to one another. So as we draw in the diagonals of the kite, and if you're thinking about an actual physical kite, these would be like where those support bars would go across. Where they meet, it's going to create 90-degree angles every time. Another one is one pair of opposite angles are bisected by the diagonal. So this is important to kind of note the difference between these two. So these two angles where the two different lengths come together, those are congruent. This is talking about the two angles where the same lengths come together. So the one tick mark, that creates this angle in here. That angle is bisected or cut in half. So if this whole thing is like 80, then this would be 40 and this would be 40. And then down here where the two tick marks come together, that creates this pair of angles, that gets bisected. So let's say this angle was 60 degrees, this would be 30 and 30. So this pair is congruent and the other pair is bisected. And then our last kite property is one diagonal is bisected by the other diagonal. Remember, in parallelograms, the diagonals bisect each other, but in this case, only one of the diagonals is bisected. It's very specific also which one that would be. That's the diagonal that connects the two congruent angles, the ones where the two different lengths come together. So remember, this angle and this angle are congruent to one another, and it's that diagonal that connects those two that gets bisected or cut in half. Hopefully you can see pretty easily this length and this length are obviously not the same, so only the one diagonal is cut in half. So let's look at applying those. We have three diagrams to work our way through. We are supposed to find the value of x in each kite. So here we have our kite, and we have a 44 degrees down here, and our x is way up there. So the first thing I'm going to do, is the first thing I usually draw in every kite, is that the diagonals are perpendicular. So I'm going to put my 90 degrees in there. Now, these two sides are the two that would be the same, and these two are the two that would be the same. So where the two lengths come together, the one tick mark and the one tick mark, this angle is an angle that is bisected. So if the bottom part of that is 44 degrees, then the top half will also be 44 degrees. Now I can focus on this triangle right here that is created, because I know that triangles always have to add up to 180 degrees. And I have this nice 90-degree angle down here in the corner. So 90 plus 44 plus x has to add up to 180 degrees. So if I want to go, I could go ahead and add those together, or I could subtract the 90 over there first. Usually students want to subtract the 90 first and just say these two are going to add up to 90, which is fine. And then subtract our 44. And we would get x to have a value of 46. Notice I have degrees marked on that because there was not a degrees marking in our diagram. I do want to note to you, while this angle is 46 degrees, this one over here is not 46 degrees. Remember, this is bisected and this is bisected. Those are the only two bisected angles. So 46 is not 46 and 46. Absolutely not. This will have its own measure over here. It will not be 46 degrees. All right, let's take a look at our second diagram. Here we have this angle being marked as 130 degrees. We have a 35 degrees over here and an x over here. Now you'll notice the x happens to be on that side over there. So how are we going to calculate this? That gets kind of tricky. So I know I have 90-degree angles. That usually is the first thing I mark. Now if this big angle is 130, then I know this big angle is also 130 because these are the two that are congruent with one another. These two sides come together over here. So if that bottom part is 35, this top part is 35. And that means this whole angle is 70 degrees. Well, trapezoids as a whole are always going to add up to 360 because all quadrilaterals will do that. So if I do 130 plus 70 plus 130 plus whatever we call this angle over here, those have to equal 360 degrees. So if I go ahead and add up these 130s, that's 260. 260 plus another 70 would be 330. So 330 plus something will equal 360. Subtract our 330 and we find out that this angle over here, the whole angle, is 30 degrees. Why is that important? Because this angle where the two lengths come together that are the same, and this angle where the two lengths that are the same come together are bisected. So that means this angle is split into 15 and 15. Now I can focus on the x appears in this triangle right here. So in triangles, we always add up to 180 degrees. So I've got this nice 90 right here. So 90 plus the 15 we calculated over there plus x have to add up to 180 degrees. Let that focus. So if we subtract our 90 over, 15 and x have to add up to 90. Then subtract our 15, and x is going to be 75. So x, this angle right here, is 75 degrees. Now you'll notice, remember this angle is not bisected, so it's not 75 and 75 because two 75s would add up to 150, and these can only add up to 130. So I could know the measure of this angle right here as well by doing 130 minus 75. And so we know this angle right here would be 55 degrees. Now the same thing would be true up here because these two triangles are congruent, and you can do that by side, 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 or side, angle, side. Whichever postulate you wanted to use would be fine. Hypotenuse, leg, any of those work. So these two are congruent with 75s, and these two are congruent with 55s. But the two that are congruent are not bisected. The other two are the two that are bisected. And then moving on to our last example, we have our diagonal lengths marked here. So remember, we have our 90 degrees in the middle, and one diagonal is bisected. So if I take a look at the congruent sides, where the two different lengths come together, these two angles, the diagonal that touches those is the diagonal that is bisected. So I know this length has to be the same as this length. That allows me to set up my equation of 3x plus 12 is equal to 7x minus 16. We have the variable on each side of the equal sign, so pick one of them to do its opposite. And we'll begin solving. So we'll bring down our 12. That gives us 4x. Bring down minus 16. We're going to add our 16 to get away from the x. So let's see, 28 is equal to 4x, divide by our 4, and 7 is the value of x. As always, pay attention to what's marked, think through what your properties are, and if you have any questions at any point, don't hesitate to contact me.